Welcome to this lesson on the null object pattern. By the end of this video, you will understand why repetitive null checks are a design smell, how to replace them with an object that does nothing gracefully, and when that solution can actually work against you. Imagine a logger that is optional. Some environments want logging, others do not. So you accept a logger that can be null. Now, every single place that calls logger.info or logger.warn must first ask, is logger not null? Miss one spot and you get a null reference crash at runtime. The problem is not null itself, it is that the burden of handling absence is pushed onto every caller, over and over again. Think about a TV remote holder on the wall. When there is no real remote, you put a dummy shell in the slot. Anyone who walks up and presses a button on the shell just gets no response. The TV does not explode, and nobody had to check whether the remote existed first. That is exactly what the null object pattern does. It gives absence a safe do-nothing stand-in so callers never need to check. The pattern defines a shared interface, call it abstract object, that both a real implementation and a null implementation satisfy. The real object does actual work. The null object implements every method as a no-op or a safe default. The client receives one of these two through the interface and calls it freely, with zero null checks. Absence is now just another valid implementation of the contract. Start with the logger interface at the top, that is the abstract object, the contract every participant must honor. Console logger is the real object, its info and warn methods write to the console. Null logger is the null object. It satisfies the same interface but every method body is intentionally empty. Nothing happens, no crash. Order service is the client. Its constructor accepts a logger and stores it. Inside place order it calls this .logger.info twice. No if check, no null guard anywhere. At the bottom we wire it up by passing a null logger, swap that for a console logger, and you get real output without touching order service at all. What the pattern really does is use polymorphism to push the conditional out of every call site and into the type system itself. Instead of the client asking, is this null? The object's type answers that question silently. Null object methods can also return safe defaults, an empty list, a zero, not just void. The key trade-off is that a missing dependency now fails silently, so a misconfiguration that should be an error can slip through unnoticed. Reach for null object when a missing collaborator is a legitimate expected state, like a logger you want to silence in tests, and that situation is scattered across many call sites. Skip it when absence is a bug, because a do-nothing object hides the problem entirely. If you only have one or two guards, optional chaining or a simple default parameter is clearer, and adds no extra class to maintain. To summarize, the null object pattern gives absence a first-class representation by implementing the real interface with methods that do nothing. That single move eliminates defensive null checks across every call site. Use it confidently when absence is expected and harmless, but treat silent no-ops with respect. If a missing dependency should be loud, let it be loud.